Welcome to a lesson with Dr. Powell. Let's take a look at the Mobius function again, and we're going to use it in another application. So posets of factors, such as the one we had before previously, do not always need to be dealt with these as the vertices. You could change this up. Perhaps let's do something like this. We have 2 to these powers. This right here could be thought of as the number of binary bit strings of length 18, of bits with 18 places and different zeros and ones. Similarly, we could think of this as being bits of length 9, this is bits of length 6. But why don't we think about this as being bit strings of length 18, but such that have a block of size 9 that repeats. So a block of size 9 that repeats, well, the whole bit string is determined by the first part of the string. There's 2 blocks, each of size 9, and the second part is identical to the first part. So how many are there with this repetition? There's 2 to the 9th. Similarly, there's 2 to the 6th that have blocks, 3 blocks, all of size 6. This is the number of bit strings of length 18 that have blocks of size 2. And there'd be 9 of those. And similarly, this is the number of bit strings of length 18 that are made up of repeating blocks. So each block is identical, of size 3, and there'd be 6 of those. And this is the number of blocks of size or number of bit strings of size 18 that are made up of repeating blocks of size 1. So in other words, all ones or all zeros. There's only 2 options. Okay, so what we're after, so suppose we want to figure out how many strings are not made up of smaller repeating blocks of size 18. Now that is what is left to add after you have everything below. In other words, it's a summand solution. We're looking for the summand solution at the top. Remember that the Mobius function can pick out summand solutions at the top. And all we need is this structure. It picks out this structure right here. And then we can just use these values as the sums or the vertices in the sum poset. So, but in order to pick out the structure, it uses the idea of the numbers in the factor poset of 18, the factorization of poset of 18, as follows. What we do is we take the numbers 2, 18, 2, 9, 2, 6, 2, 3, 2, 2, and 2, 1. The factors of 18, these are all the numbers that were in that poset representing different blocks. Now, if I multiply by mu of 18 over 18 times mu of 18 over 9, notice the 9 goes right down there, times mu of 18 over 6, times mu of 18 over 3, times mu of 18 over 2, times mu of 18 over 1, and add all these up, I should have the number of primitive bit strings, which are strings that don't have any repeating blocks of size 18. We'll call those primitive, not made up of any smaller repeating blocks. If this should be what we desired, and we'll label that the number of primitive bit strings, binary bit strings, of length 18. So remember how this computes. So this is 9 and 18. These guys have a factor of 9, so they're wiped out. Yeah, Mobius function there is 0. Then what about up here? So this is 6, 2 prime factors, so that's a positive 1 times 2 cubed. This one is 3, so that's negative 1 times 2 to the 6. This is 2, so negative 1 times 2 to the 9th. This one is 1, so that's a positive 1. So positive 1 times 2 to the 18th. Add these guys up right here. And that's the result right here. We would end up getting that. Thanks for watching.